Hey, this is Mr. Mola. Just going to go through a quick video with you to help you with this quiz for using function notation. So this one asks, what is the domain of the function represented by the graph? So if you remember, domain are all the possible x's on a graph. Ranges are all the possible y's. And then another important thing here is these arrows. Arrows means the graph goes on forever. If it's a dot, that means the graph stops. But since there's arrows, that means it goes on forever. So even though the biggest number we see on this graph is 4, the graph is still going to go on to 5 and 6 and 7 and 8 and 9. And the same thing over here. The smallest number we see is -4. There's still a -5 and a -6 and a -7 and -8 over here because the arrow means that it goes on forever. And since it goes on forever, there's an infinity amount of numbers that it could be. So another way to say infinity is math is all real numbers. Here, Riza paid $4,500 as a down payment for a car. So when you buy a car, your down payment is the thing you pay one time. Then she made equal monthly payments of $250. So that means she's going to keep paying $250 off every time because we're doing that every month. So usually if you see the word monthly or equally or daily or something like that, that's the thing you pay each time. She paid a total of $10,500 for her car. How many months did she make payments for in the car, and which function will be used to find the answer? So $4,500, she's paying that one time. So it's not going to be this one with the 450x because she's just putting down a down payment one time. The x is going to go with the 250 because that's the thing that you pay over and over and over again. That's the thing that repeats. So it's going to be that first one. The table represents a function f of x equals 2x plus 1. What goes in the empty one? So here it's telling us that x is 2. So 2 times 2 is 2. Or 2 times 2 is 4, not 2. So 2 times 2 is 4. 4 plus 1 is 5. So 5 would go into the empty column there. Function represents, or these pair, how many elements are in the range of this function. Range is all the y's. So 9 is x, -3 is y. 10 is x, -2 is y. So how many of those are in the second column here? And this one's kind of tricky because we have a -3, a -2, a -3 again. So we're not going to write -3 twice. And then we even have a -2 again. So they tried to trick us 2 times. So we're not going to write -2 twice. So really we have a -3, a -2. Not going to write that -3 again. Not going to write that -2 again. 2 and -1. So there's 4 different numbers in the ranges, in the y's for that question. Jalen went to a music park. They charged $10.50 as an entry fee and $4.50 for every ride. Wow, that's expensive. Jay spent $46.50 on entrance fees and rides. So same thing on every ride. So that's the one that's going to change. He's paying $10.50 to get in, kind of like the car problem. $4,500 down payment, $10.50 to get in, so $10.50 one time. $4,500 on the car problem one time. And then $4.50 for every ride. So that's the one that's going to get the X there. So $4.50 for every ride plus $10.50 to get in. So it's going to be that first one. The table shows the data collection to represent a functional relationship between the number of hours of an auto factory is open and the cars produced. What is the domain? So that's all the X's represented by the table. And there's all the X's there. It could be open for 1 hour. It could be open for 2 hours. It could be open for 3 hours. So that one's kind of tricky there because it says 3, 5, 7, 9, 11 like you picked. But really a car shop could be open for any amount of hours, right? It's not just open for 3 hours a day. It might be open for 1 hour a day or 2 hours a day or 3 hours a day. So it could be open any amount of hours, really. So anything greater than 0 hours, or it could be closed for the day and then it's equal to 0 hours. Hope that helps.